We've said that power measurement in a wireless system, along with other systems, is going to be done using the relative tool of decibels, right? We can measure absolute power in terms of electricity and current through our wattage, right? So how much wattage are we delivering to the system? How much energy is being used? But we can also look at it in terms of decibels. And we talked about that idea of dBm, so decibels relative to milliwatts, right? Milliwatts of energy. Well, there's another time when we talk about our decibel systems in Wi-Fi, and that's when we're looking at it in terms of the power of the antenna. Because certain antennas are going to radiate power differently than other antennas, and we need to measure it in terms of, okay, how much oomph is that antenna going to give to that signal in different directions? One tool of measurement for managing antenna power is to describe it in terms of dBi, which again is decibels, the same logarithmic scale, relative to what's known as an isotropic antenna. What's an isotropic antenna? An isotropic antenna is a perfect antenna. It's an imaginary antenna. It doesn't really exist, but it says, okay, if I just could have an antenna that was a single dot in space, perfectly spherical, that radiated power, radiated that electromagnetic wave equally in all directions, I've got myself the isotropic antenna. So it's a mathematical construct. It doesn't really exist, but we can use it as a way to describe the antenna that do exist relative to that system. What it boils down to, gang, is that we can say that if I have one antenna and it, say, had a 3 decibel power, well, that would mean if we've got our baseline of 0 to 1, that's the way that the logarithmic scale works, then if I have doubled the power of that baseline system, then I have 3 decibels, dBi. If I double the power again to 4, I'm now at 6 dBi. So what can you say about two antennae? One's 3 dBi, one's 6 dBi. You can say the 6 dBi is twice as powerful as the 3 dBi. Or if it's radiating power in a certain direction, you can say it's 6 dBi in this direction, but only 3 dBi in this other direction. You can say, oh, well, this puts twice as much power. It's pushing that wave out with an amplitude that is twice as high in this direction than it is in this other direction. And that's the point, all right, of having these measurements, is so that as we have this perfect access point, so we have this antenna that's radiating out this wave, we have a way to measure its strength separate from the current that's going into it.